mission program. It's 15 years old this year. This is the first time we brought the entire group of mission managers, scientists, project scientists together as a community to look back and assess what we did and look forward to how we can do it better.
So what do you think are some of the highlights then of what the program has brought forth so far?
Wow, it's been groundbreaking. You know, we did the first rover on Mars, the first comet sample return, the first landing and orbiting of an asteroid. We discovered strong evidence for water at the poles of the moon. I could make a longer list. It's really just mind-blowing.
What do you see for the future of the Discovery program?
Well, I think it's going to continue to be very successful, very strongly responded to by the scientific community. We're going to try and now expand the kinds of missions that we can do within the same budgets, but to more kinds of locations to do even better science.
And I understand you actually have a connection yourself to the Discovery program.
Well, a little one. I was on the original Discovery Program Science Working Group that sort of architected the whole program in 1990 and 91.
We look forward to seeing a lot of what the Discovery program has in store for the future. In fact, I believe Lori is with one of the mission managers of the Discovery program.
I'm here with Kara Patel, and he is the project manager for the Dawn mission from the Jet Propulsion Laboratory. Tell me about the Dawn mission.
Well, Dawn mission will be going to the two of the biggest asteroids in the solar system, Vesta and Ceres, and it's going to orbit both those asteroids and try to determine the chemical composition and makeup of both those asteroids.
And why would we want to know something like that?
The two of the biggest asteroids, they're located in the asteroid belt between Mars and Jupiter, and their formation was stopped by big old Jupiter sitting out there. And what we believe is the pristine material from the early formation of the solar system is still present there, and this will give us an insight on what the early solar system looked like.
And how long does it take to plan and actually get through a mission like this?
This mission's been going on, this Discovery mission's been going on for a number of years. The science team, or the PI, did actually propose this mission a couple of times before it was selected. And so once it was selected, this mission's been in development probably for the last 5 or 6 years.
And how have you been working with the Marshall Center on this mission?
Marshall has the program office, the Discovery and the New Frontiers program office, and the program office consists of a number of projects, and this is one of the Discovery projects that's within the program office, plus all the other Discovery missions that are underneath the program office.
All right, well, thank you so much for joining us.
Thank you.
William Barucki joins me now, and he's the principal investigator for the Kepler mission. Now, tell me about what is the Kepler mission exactly?
The Kepler mission is a telescope that we're putting into space that measures the brightness of 100,000 stars, looking for Earth-like planets around other stars.
Earth-like planets. So there may be other planets like us out there.
That's right. So what we're doing is looking for the size of planets, just about the size of the Earth, in the habitable zone. So if they're in a habitable zone, we might find planets where there could conceivably be life. On the other hand, if we don't find any at all, and we look at 100,000 stars, that means that Earth might be very rare. We might be the only civilizations in our galaxy.
So when does this launch, and when will we be able to get to see the results?
This should launch in early 2009, and about a year later we'll get our first results. And then we should start learning about the planets around the dim stars. A little bit later, stars closer to the sun. So it'll be a few more years after we launch before we can tell you, are there Earths out there around stars like our sun?
And you're very familiar with NASA. You've been with NASA for a long time, and all the projects that take a while. This project, I'm sure, will take a while as well. It's taken a while to develop, and it's taken a while to get to 2009. But you worked on the Apollo heat shield, too, you tell me. Tell me what it's like to go from that to this program now.
Actually, working for NASA is very, very interesting. You work with a lot of different groups. I worked on the Apollo heat shield. I worked on atmospheric models to see how the ozone would change with chlorofluoromethanes, the freons. And, of course, worked actually on lightning and other planets, and now on trying to find planets like the Earth around other stars. And it's been a very interesting career.
And as a principal investigator, you have a really good relationship with Marshall, right?
We have a wonderful relationship with Marshall. In particular, this mission to find planets has been helped tremendously by their optical department, and they've helped us solve problems that we were stuck on in terms of could we get the filters to work properly, could we get the optics to do what we needed, and they were able to give us the help so we could continue on with the project. It's been wonderful working with the people at Marshall.
All right, well, thank you so much for sharing your mission. Good luck with it.
Thank you.
I'm here with Paul Gilbert, and he's the Discovery New Frontiers Program Manager here at Marshall. And Paul, you're celebrating 15 years with the Discovery Program.
That's right, and the Discovery Program has been a really great program for NASA. It started in 1992, and it was established to do solar system exploration.
And what exactly is that?
Well, that's a really good question. Solar system exploration would be to look at the origin of our sun's planets and its minor bodies. How did they originate? How did they evolve? The other thing is the origin of life. How did life come about on Earth? How would it spread through the solar system? What are the conditions? And finally, there is a tie to the exploration vision. What are the resources and the hazards as humans go out into our solar system? So there's many aspects to this program.
And someone might say that Marshall is known for human spaceflight. How did we get involved with these missions?
The way we got involved in these missions is that NASA was looking for a home for the Discovery Program Office, and they were looking for some group that had good flight project management skills, good system engineering skills. And of course, our center with human spaceflight has the type of skills they were looking for, and so they located it at Marshall. This has opened up a whole new unique field for our center, which is we have a lot of work we do now with the Jet Propulsion Lab, with the Johns Hopkins Applied Physics Facility. Goddard Space Flight Center is proposing on some of the missions. So instead of just working with the human-related centers, we're working with the robotic centers now.
Now, as I mentioned, you're celebrating 15 years, but there have been a lot of firsts with this program, right?
There have been a lot of firsts, and people don't realize the first Mars rover, Mars Pathfinder, actually came out of the Discovery Program. The first mission to capture some of our sun, bring back some solar winds, was the Genesis project. The first mission to bring back some dust from a comet tail was the Stardust mission. The first mission to punch a hole in a comet to see what the interior was Deep Impact. And the first mission that will use ion propulsion to actually conduct a science mission is the Dawn project.